Alright, so we're going to take a look here at a number of properties of limits. In another video, we'll go farther in depth and a little slower through each one. But this is just a quick overview of the properties we've got here. So this first one here, the limit as x approaches c of a number n times f of x. So here we're going to say n is a number like 3, 4, 2/3, 7/8, whatever, just a number. And what we can do is we can write that number outside of the limit, meaning we evaluate the limit and then multiply it by that number instead of worrying about it being multiplied within the limit there. So it would become n, or the number, times the limit as x approaches c of f of x. And that's going to be basically the pattern here the whole time, something like that. We just move some stuff around. So for the second one here, the limit as x approaches c of f of x plus g of x. We can add the functions first, like it would be written here, and then evaluate the limit. Or we can evaluate the limit of each piece. So this becomes the limit as x approaches c of f of x plus the limit as x approaches c of g of x. And the same sort of thing here happens with subtractions. This becomes the limit as x approaches c of f of x minus the limit as x approaches c of g of x. And it's going to be the same pattern for the next two. If we have a product of two functions, multiplying the two together and then evaluating a limit is going to be the same as evaluating the limit of each of them separately and then multiplying those results together. So this is the same as doing the limit as x approaches c of f of x times the limit as x approaches c of g of x. And the same thing here with division. There's going to be one little thing we're going to have to worry about, but the limit as x approaches c of f of x over the limit as x approaches c of g of x. And something to mention here, this only works if the bottom function isn't equal to 0. You can't have a 0 in the denominator there, and you can't have 1 over here. So the limit can't be 0 either. And then this last one here is a little stranger. We're going to look at an example on the next page of this. This becomes the limit as x approaches c of f of x, and it's the entire thing raised to that exponent power. So before it was the limit as x approaches c of f of x to the n. Now it's the limit as x approaches c f of x, this whole thing raised to the n power, whereas over here was just the function raised to the n power. So we're going to take a look at these examples here. If the limit as x approaches 4 of f of x equals 7 and the limit as x approaches 4 of g of x equals 3, evaluate the following. So we've got two functions here, f and g, and we know that as we approach 4, f of x goes to 7, g of x goes to 3. So this first one here, the limit as x approaches 4 of 3 times f of x, we know from before that's the same as doing 3 times the limit as x approaches 4 of f of x. And this part right here, we know from above, is equal to 4. So, sorry, not 4, is equal to 7. So this is 3 times 7 is 21. The second one here, the limit as x approaches 4 of 1/2 g of x minus 2 f of x. So first we've got subtraction here, so we can separate this into two limits. The limit as x approaches 4 of 1/2 of g of x minus the limit as x approaches 4 of 2 times f of x. And then we can do the same thing we did in example A here with these numbers in the front of the functions. We can pull those out to the front, so it becomes 1/2 the limit as x approaches 4 of g of x minus 2 times the limit as x approaches 4 of f of x. And then we can evaluate these parts in here. We know the limit as x approaches 4 of g of x is 3. We know the limit as x approaches 4 of f of x is 7. So we have 1/2 times 3 minus 2 times 7, which is going to be negative 12.5. And finally down here we have one that's a little bit more difficult. The limit as x approaches 4 of the cubed root of f of x. Now this matches with the last property we had in the previous slide. What you've got to remember here is that we can rewrite a cubed root as an exponent. So we get the limit as x approaches 4 of f of x, to the 1/3 power. So this 1/3 goes outside the whole thing, so it becomes the limit as x approaches 4 of f of x, all to the 1/3. And then we know the limit as x approaches 4 of f of x is 7, so it's 7 to the 1/3, which you could just leave as 7 to the 1/3 or write as the cubed root of 7 if we'd like.